Compound probabilities, independent events. A compound probability is the probability of two events occurring. The probability of A and B is equal to the probability of A occurring times the probability of B occurring. Independent events are two or more events in which the outcome of one event does not influence the outcome of the other event. So suppose you have a sock drawer that contains 5 blue socks, 8 green socks, 4 yellow socks, and 3 purple socks. After replacing the first sock, determine the probabilities and show your work. So let's go ahead and make ourselves a chart here so we can easily calculate all these compound probabilities. So first let's look. We have 5 blue socks. We have 8 green. We have 4 yellow. And we have 3 purple. That makes a total of 20 socks. So let's calculate the probability and reduce it for each sock, color sock. So we have 5 blue out of 20 socks, so your probability would be 5 to 20, which is 1/4. The probability of getting a green is 8 out of 20, which is 2/5. The probability of pulling a yellow sock is 4 to 20, which is 1/5. And the probability of pulling a purple sock is 3 out of 20. So now that we've calculated these probabilities, we can easily calculate the compound probability. So what is the probability of pulling a green sock and then replacing it with a blue sock? Well, the probability of pulling a green sock is 2 to 5, or 2/5. And the probability of pulling a blue sock is 1 to 4, or 1/4. So we just multiply the two probabilities together, and we get 2/20, which simplifies to 1 to 10. So 1/10. So go ahead and calculate the probability of pulling a yellow sock, replacing it, and then pulling a purple sock. So that's 3 to 100, or 3/100ths. Now calculate the probability of pulling a green sock, replacing it, and pulling another green sock. So that's 4/25ths. Now calculate the probability of pulling a red sock and then a purple sock. And the probability of doing that is 0 because there are no red socks. Calculate the probability of pulling a purple sock, replacing it, and pulling another purple sock. Nine 400ths. And calculate the probability of pulling a yellow sock, replacing it, and then pulling a green sock. It's 2/25ths. All right, now let's change it a little bit. We have a coin is tossed and a die is rolled. Find each probability and show your work. So the probability of rolling heads and pulling the number and spinning the number 4. So the probability of tossing tossing a coin and getting a heads is 1 to 2. And then the probability of rolling the number 4 is 1 in 6. So 1 in 12. So 1/12 is your answer. So go ahead and calculate the probability of flipping a coin and having it come up on tails, and then rolling a die and getting the number 1. Again, that's 1/12. 1 and 1/12. 1/12. Number 9, what's the probability of flipping a coin and getting a heads, and then rolling a die and having it land on an odd number? That's 1/4. Number 10, what's the probability of flipping a coin and getting a tails, and then rolling a die and getting a number less than 5? That's 1 to 3. What's the probability of flipping a coin and having it land on heads, and then rolling a die and getting a prime number? And that's 1 in 3. In our final example, what is the probability of flipping a coin and getting a tails and rolling a die and having it land on an even number?